In the last videos we talked of adsorption. Basically what absorption is, I have drawn a structure like this, and the foreign particles, when they adhere themselves over this surface of any substance, this process is known as adsorption. Now basically let's look at this adsorption. See, the force of attraction between the particles of surface and these foreign atoms, may be gas or liquid. It is basically the force of attraction between them which held these two particles together, and these foreign entities form a surface of them over this surface here. A layer of these molecules will be formed over this surface. Now adsorption is classified in two types depending upon the nature of this attractive force between this particle and the solid particle. First one is physical adsorption, or it is known as physiosorption. Physical adsorption. And second one is chemical adsorption. Now what is this physical adsorption and what is this chemical adsorption? Let's talk of this physical adsorption now. When this attractive force between this foreign particle and this surface particle is weak forces, I hope you know. For example, van der Waals force. Van der Waals force. This is a weak force. When this is between these two particles, this type of adsorption is known as physiosorption. And I hope you have guessed for this time, this chemical adsorption will be the adsorption when this force of attraction between these two particles is strong. There's a strong chemical force between these two particles. This type of adsorption we will call that chemical adsorption. And this physical adsorption is just there is a small weak van der Waals force between these two particles. That type of adsorption is known as physiosorption or physical adsorption. Let's move to the next slide. Wait a second. Now let's look at some details. Let's talk of this physical adsorption. See, consider this as a solid surface and we put it in some container like this, and here is a movable piston over here. This is a movable piston. This is piston, and this is our surface, and here these are the gas particles. Now let's talk of this physical adsorption first. Now assume we have put some weight over here, over this piston. Obviously this piston will move downwards. What will happen to this gas? Now piston is here, this gas will get compressed. The pressure inside, basically the pressure inside will increase, and more particles will be adsorbed on this surface. That means this physical adsorption, we can vary this physical adsorption, rate of physical adsorption with pressure. This is the first term. Second, if we increase the temperature of the system, these particles which were adsorbed over here will gain energy, thermal energy, and particle gaining energy will try to free itself and move in its own gas phase. So temperature decreases the rate of adsorption, and pressure indeed increases the rate of adsorption. I hope these two terms are clear. Now talking of the physical adsorption, as you know, in physical adsorption, the force of attraction between these two particles is weak. There is a weak van der Waals force between these two particles. So the characteristics of this physical adsorption are like this. First characteristics, sorry for this characteristic. First, it will be reversible. How? No prize for guessing. If we decrease the pressure and increase the temperature, the rate of adsorption will decrease. Obviously pressure increases and temperature decreases. Now if we reverse the both, we decrease the pressure and increase the temperature, the rate of adsorption will decrease. That means this physical adsorption, first one which I are discussing, this physical adsorption is reversible in nature. It is reversible in nature. Second, it depends upon the surface area. What do I mean by that? If we have a small surface, obviously less number of particles will get adsorbed over here, and if we have a larger surface area, more particles have the chance to be adsorbed over here. Third, as there is a strong force of attraction between these particles and the particles of surface, there is a strong force of attraction, so we need a less amount of energy to break the bond between them or to free the foreign particles from this surface. That means, enthalpy of adsorption is small, less or small, whatever you say. Now talking of the second type of adsorption now, that is chemical adsorption. Now I think all of you should be able to answer this. There is a strong force of attraction between the particles of surface and the foreign particles. They form a kind of bond. There is a type of chemical bond between these two particles. So this chemical adsorption, this will be irreversible. It is not easy to break chemical bonds easily. That's why this chemical adsorption is termed as irreversible. No doubt these particles can be separated, but they need some different type of procedures. Second, same one, it's surface area. More surface area, more adsorption. And the third one, it is enthalpy. I hope you have guessed till this time. Enthalpy will be higher than the physical adsorption. And the fourth one is, see, in this chemical adsorption, there's a kind of chemical bond between these particles. So these particles form a layer over this surface. These are the foreign particles which I am trying to make over here. Now once these particles cover this surface, the new foreign particles which may try to adsorb over here cannot adsorb because the surface is not available. That is why in this chemical adsorption, the foreign particles form a single less